good morning. Let me get through the door. Science fans, what have we got? Book 2, page 322, the moon. Book 3, 107, sun, weather. Well, not much sleep going on. Every time I go to fall asleep, a cluster wakes me up. So I'm going through that phase where not much sleep. But it's good because I've been reading Enter the Mind of a Conspiracy Theorist. Let's go for a ride. What have we found? As you know, we snagged us some 1961ers. Some 1961ers. Fascinating. The power of suggestion is what's happening. How many times have I said before, they put things in, they drip feed things in. Huh. So book 1, I'm only speed reading, and I'm speed reading the space stuff, stars, etc., right? Right, what kind of view have we got here? So this is it, 1961, right? So this is how it's broken down. See that? The universe, study of the universe, the face of the sky, the constellations, the earth, the birth of the earth, the weather problem, right? All this stuff. 1961. It's fascinating, right? How molecules behave inside the atom. It's just unbelievable science through the ages, right? It's hard to explain, but only because I think a certain way, right? Now, how many times have I said they drip feed stuff into our reality today, right? And I'm more convinced of it now than I have been, right? Okay. So, good if somebody else could open up maybe in the mornings, eh? We're doing driver's jobs here. It's much. Don't do driver's jobs. So, what we have in the mind of a conspiracy theorist, this is how we think, okay? Well, me personally. So we've got the present. Alright, we've got past. Alright, so we've got the present here. Alright, got the past, which is history, and then we've got the future. But we always live in the present, right? We're always here. So when we go into the future, when we are, but we're always here in the present. This is it. Here. Everything happens here, right? Now, this, for example, I've got this sort of, it's hard to explain. Right. So something happens, right? Oh, look at that. No, far out. That's unbelievable. How did they do that? There is no way. Hang on. Look at this. Oh, so 40 years ago they did this, which is now why they can do that. But didn't happen, right? It did not happen. They've tweaked the future, but in the present, but they tweak the past in the present. So it's almost like humanity's going, oh, wow, and they tick, give us a tap. Oh, future. Oh, no. Tick. Oh, yeah, look, no, it's back there, see? It's like we're being herded. It's hard to imagine this, but let me show you what I mean. You have to be able to use empathy for this. Don't forget, we are always here, right? Tomorrow will be the future, but we will still be here. This is key, right? Talk about mind games, folks. It's early, I understand that. Right, put that in the pew. Now, I've been reading those books, speed reading, right? Speed reading. Right, now, book number 1, so many names. I am talking about the amount of names of people. So we've got Newton, we've got Kepi. Oh, Kepi, I was wrong about Kepi. Well, I'm not going to say I was wrong about Kepi, but he's in this 1961 stuff. But I'm on end of book 3, right? Speed reading all the good stuff, only space stuff. And I gave up book 1. I said, right, I'm not going to write everything down, just stuff that really smacks out at me, right? So book 2, 322, right? The Moon. So this is in 1961, remember? 1961. This is written in 1961, right? So this is all about gravity, right? The center of gravity, forces of gravitation. You know, it's good. It's good. So Newton comes in, but there's so many names, right? That just forget about it. I mean, we are talking about just, listen, it's impossible to track. If you start to do like a family tree of scientists, all right? The last bit of it, gravitational attraction on the moon. It appears likely that man will land on the moon in the not too distant future. Will he find that the same forces of gravitational attraction will hold for the moon as for the Earth? If he drops a ball from a height on the moon, will it fall to the moon's surface? If he strings a heavy wire between 2 high places, will it sag downward? The answer is yes. However, a traveller from the Earth would find that the forces of gravitational attraction would not be nearly so great on the moon as on Earth. We say 1/6 of the gravity, right? Because the mass of the Earth is so much greater, bigger, more pull. We're heavier, right? The acceleration due to gravity at the surface of the moon would be about 6.7 feet per second, as against 32 feet per second on the Earth's surface. Now, right, let's go. The acceleration due to gravity at the surface of the moon would be about 6.7 feet per second, as against 32 feet per second on the Earth's surface. In 3 seconds, an object dropped from a height on the Earth would travel a total distance of 144 feet. Right? So, what they're saying is, if I drop this, don't be mind if it breaks. Right, look. This eraser, right? In 3 seconds, an object dropped from a height on the Earth would travel a total distance of 144 feet. 1, 2, 3. That's 9.2 meters per second. That's 27. That's not 100%. They say it's 9.8. Anyway, this is 1961. 1961. Okay, so that's 3 seconds, right? The same object dropped from a height on the moon would fall a total distance of only about 30 feet in the same period of time. So they're saying if we drop something on Earth, right, these 2 same objects for 3 seconds, right? One on the moon and one on Earth, right? The moon one would only go 30 feet, but the one on Earth would go 144 feet because of the extra gravity. But in a vacuum, remember this is 1961, right? Right? So in 3 seconds, an object dropped from a height on the Earth would travel a total distance of 144 feet. The same object dropped from the same height on the moon would fall a total distance of only about 30 feet in the same period of time. So they're saying it's going a lot slower. But it would start to speed up with no resistance, wouldn't it? Anyway, because of the lessened gravitational force on the moon, our traveller would be able to perform feats that would be quite impossible on the Earth. He would be able to carry with ease objects that on the Earth would tax the powers of a champion weightlifter. He would be able to run like a deer and to jump to fantastic heights. The world's record for the high jump is about 7 feet. Even without any kind of athletic training, our traveller would be able to clear the 25-foot mark on the moon without any great effort. He would be able to do other remarkable things. Now, this is in 1961. This is when the space race started. They just started sending stuff to the moon, or to space. The Apollos were going up. Now if this isn't the power of suggestion, right? If this isn't the power of suggestion, I don't know what is. But still, I still have not found Lagrange or Roma. They've talked about the speed of light, and even in 1961, it said that the speed of light was 186,000 something miles per hour, which in miles, I always thought kilometers, 299,000. But there is no mention yet of how or who discovered the speed of light. And I'm reading all of this stuff, right? Only the universe, the sun, our stars, shadows in the heavens, the family of the sun, the climates of the past, plant life, forget it, animal life. I'm not doing those, right? Matter and energy, I'm giving that a quick scan. All right, science through the ages. It's too gappy, and there is way too much information, right? So this already started. Book 3, 107, Sun and Weather. Right, listen to this. Oh, I put my eye out. My car might have to go back to the shop today. Computer. I'm loving the scooter at the moment. All right, where are we? Page 107, right. Just reading the bits of speed reading, right? The amount of heat received from the sun seems to vary according to the cycles. A Smithsonian Institution team, headed by Charles G. Abbott, suggested that fluctuations in solar radiation never exceeding 3% accompany the various phases of sunspot activity that have been noted by astronomers. Other investigators, however, are rather inclined to doubt the conclusions reached by Abbott. Sunspot cycles undoubtedly have subtle effects upon the weather, which is controlled to a great extent by the radiation emanating from the sun. Any changes in the nature or the quantity of this radiation Changes such are associated with the sunspot activity are bound to have a vital effect upon the weather. Attempts have been made to present long-range weather predictions based on sunspot activity. These attempts have not been particularly successful so far. They have been complicated by the fact that weather represents the interaction of a good many different factors. Winds, ocean currents, large land masses, lofty mountain ranges, and the like. The years ahead, however, may see great advances in research on the different ways in which the sun affects our weather. Good science. It's very, very difficult, right? Now, I finished this book, but just see at the microscope, the beginnings of true chemical science, right? Perhaps the outstanding iatrochemist of the 17th century was Jan Baptista van Helmont, 1577 to 1644. A warm-hearted Belgian nobleman and physician, he was the first to distinguish different kinds of gases from ordinary air. In fact, he invented the word gas. It represented the Flemish version of the Greek word chaos. Helmont talks about windy gas, smoky gas, fat gas, wild, he taught his concept of gas. See, they go into this real big deep. Helmont proposed a curious theory that all tangible bodies are the product of water only and may be reduced to water again by nature or art. To prove his point, he put a small willow tree weighing 5 pounds. How do they know all this stuff, right? It's 1577. For close to 400 years. Another one, look. The German Johann Rudolf Glauber, 1604 to 68, was an iatrochemist who earned a fat living by selling secret chemical and medicinal preparations. He won fame for a substance that he called the wonderful salt, and that is today called Glauber's salt after him. Oh God, look. With Robert Boyle, 1627 to 91, we came at last to true scientific method in chemical research. This gifted man, who was born in Ireland, studied at Eton, and then travelled widely on the continent, was one of the first members of the Royal Society and one of its leading lights. Boyle did much to rid chemistry of the trappings of alchemy. In his Skeptical Chemist, published in 1661, he insisted that chemistry was a science and not simply a practical system for treating metals or... Look, I don't know. There's something too... Boyle came to the conclusion that the life of animals is just as dependent upon that mysterious part of the air as the flame. What is light? What is colour? How do we see? Questions like these disturbed men's mind from early days. Pythagorean theorised that vision was due to particles emanating from the eye. The idea of the wave theory of light was hinted at by Leonardo da Vinci and by Galileo, we're back in the 1600s. It was definitely suggested by a Bologna mathematics professor, Francesco Maria Grimaldi, 1613 to 63, 1600s, who thought of light as a fluid capable of moving in waves like any other fluid. Grimaldi made other contributions to the science of optics. He discovered, for example, that rays of light could be deflected as they passed by the edges of thinner opaque bodies, producing the phenomenon called diffraction. This is 200 years before bulbs, before electricity was in homes. So he was using just the light from the sun. Look, the foremost champion of the wave theory of light was the Dutch mathematician, astronomer and physicist Christian Huygens, 1629 to 95. This thoughtful and imaginative man made notable contributions to science. He developed the telescopic eyepiece that has since been known by his name. He discovered the rings of the planet Saturn. He applied the pendulum to the regulation of the movement of clocks. Newton drew among Huygens' claim. He presented this theory to the public in his treatise on light, 1690, but he had worked out its detail long before. He held that the different points of a wave, front or wave crest of light, set up on an infinitely numerous series of secondary waves. These secondary waves reinforce each other after a time and produce a new wave front. Other secondary waves arise, and these result ultimately in still another wave front. Thus, light is propagated. Now, this stuff is in the 1600s. There was no electricity. Waves have to move in some medium or other. Huygens felt that this medium could not be air, since it was well known that light rays could pass through a vacuum. He therefore assumed the existence of an all-pervading mysterious ethereal substance, the ether, as the medium through which light waves travelled. The ether taught was made up of small, hard and elastic particles which transmitted the wave impulses without being permanently displaced themselves. This invisible, intangible ether was destined to trouble men of science for several centuries. Today, a few physicists will concede its existence. See, this stuff goes, it's drummed in. There's what evidence is there? All there is this, right? How Kepler explained vision. Various explanations of vision were offered in the 17th century. The astronomer Johannes Kepler proposed a theory that comes astonishingly close to our modern ideas on the subject. I wonder why. He held that rays were refracted, bent by the crystalline lens of the eye in such a way as to form an inverted image on the retina. When this image is transmitted to the brain, vision takes place. Kepler correctly explained far-sightedness and nearsightedness on the basis that in one case the light rays reach the retina before coming to a focus, and that in the other case they come to a focus before reaching the retina. This is before electricity. This is before Newton gave the first satisfactory and generally accepted explanation of colour phenomena. He began by experimenting rather idly with a prism, the wedge-shaped glass that causes the light of the sun to be broken up into a spectrum or series of colours ranging from red to violet, as are seen in a rainbow. In the year 1665, he wrote, "I procured a triangular glass prism to try therewith the celebrated phenomena of colours. Having darkened my chamber and made a small hole in my window shutters, to let in a convenient quantity of the sun's light, I placed my prism at its entrance that it might thereby be refracted to the opposite wall. It was at first a very pleasant divertisement." Newton then proceeded to make a serious study of colour phenomena. By an ingenious arrangement of prisms, lenses and screens, he succeeded in demonstrating that white light or sunlight is a most surprising and wonderful composition of the colours of the spectrum mixed in due proportion. 1961, remember? He showed that each colour of the spectrum, ranging from red to violet, has its own degree of refraction. That is, that it is bent in just one direction. Today, we would say that each colour has its own individual wavelength. Newton studied... Here we go. Oh, listen to this. Other men who shed light on the problem of light in the 17th century should be mentioned here. Descartes thought of light as a kind of thrust or pressure from luminous bodies and attempted to explain its refraction in mechanical terms. He used the illustration of a man hitting a tennis ball against a flat surface or through a curtain. Willibrord Schnell, fast in German, Schnell, 1591 to 1626, 9, only 35. Dutch professor of mathematics at Leipzig, formulated but did not publish the law of refraction that bears his name. Pierre Fermat, 1601 to 65, a mathematically minded magistrate of Toulouse, formulated the principle of least time for the transmission of light and showed that its velocity would be less in a more highly refractive medium. The Frenchman Edmond Mariotte, 1620 to 84, who explained the halos occasionally seen around the sun and moon, also made the discovery of the blind spot in the eye, where the optic nerve joins the retina. One of the most significant scientific advances in the 17th century was the realization that light does not travel instantaneously as the people. One of the most significant scientific advances in the 17th century was the realization that light does not travel instantaneously as had been informally assumed, but requires time for its propagation. Galileo advanced the belief that light has a definite velocity, and he had tried to measure it, but the speed of light was too great to be measured by the crude. It was the Danish astronomer Olaus Rømer, 1644-1710, who first definitely demonstrated that light has velocity and who gave the first approximate idea of its high speed of travel. Working at the Paris Observatory in the 1670s, he observed a series of eclipses of one of the satellites of Jupiter. According to some scholars, he used a series of I swear to God, right? I promise this is not a setup. According to some scholars, he used a series of observations made by the Italian astronomer Giovanni Domenico Cassini several years before. He noticed that the eclipse succeeded each other more slowly when the Earth, in its orbit, was moving away from Jupiter. This is 1961. He noticed that the eclipses succeeded each other more slowly when the Earth, in its orbit, was moving away from Jupiter than when it was approaching. So, here's Jupiter. Oh, Roman 1961. Far out. Tell you what, don't. Lagrange, right. Jupiter. And Sun. And then we've got Earth, right? So orbit. Right. So he came to the conclusion that the farther Earth was from the satellite, the longer. Where was I? Right. He noticed that the ellipses succeeded each other more slowly when the Earth in its orbit was moving away from Jupiter. So when Earth was going this way, right? So Jupiter takes 12 years. Right? So for every half, or for every one orbit, Jupiter does 1/12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So we do 1. Let's get rid of that line. Oh, Roma. I've been about a bit, isn't he? Fucking old Roma. Right. So we start here. We go around once. Jupiter in the our once has gone to 1. We go around again. Jupiter goes to 2/12 or 1/6 of its orbit around the Sun. He came to the everything made by moving away from when it was approaching. He came to the conclusion that the farther the Earth was from the satellite, the longer it took light rays reflected from the satellite to reach the Earth. So the further Earth was that way, away from Jupiter, the longer it took the light of the Sun to bounce back. So when he was over here at the furthest, because the light took that long, right? And that was the light delay. using the time of the eclipses as a basis. Now listen, right, listen. We're 150 million kilometers, right, from the sun. 150 million, right? When we're over here, Jupiter is 750 million away from the sun. Not from us, from the sun, right? So if Jupiter from the sun is 743 million, right? And we are another 150 million, that's nearly 900 million, it's nearly 1 billion kilometers, isn't it? Right? And he, in 1676, picked out Io, right, as it pops out once every 42 hours. And that is the distance, he said, when we were coming closer, closest to Jupiter, right, it was quick, and then as we moved away, because of the distance, the light takes longer to bounce. But he was looking with a telescope, wasn't he? And if you're looking with a telescope, right, this is it right here, folks. This is it right here. If you're looking at Jupiter with a telescope, it does not matter how far away you are from Jupiter, because your eyesight has gone to Jupiter. You're not waiting. It doesn't matter how far back you are, does it? It does not matter how far away you are, because you're looking at Jupiter with a telescope. So what difference will it make? That's not going to... Oh, it's coming out later because I'm further away. You're using a telescope. It wouldn't matter if you were 20 billion kilometers away. If you had a powerful enough telescope, you're going to see Jupiter as it is, aren't you? You don't need to wait for the light to bounce. Because eyesight is instant. I can look up now, if Saturn's in the sky, boom! It does not make any difference if you're looking through a telescope. Oh, Roma, this did not happen. It did not happen. This has been planted. Far out. This is fucking fantastico. I'm telling you, folks, they're making claims today. They're making claims today, right? It's like they were running before they could walk with the moon, right? They went for it. They took all the lollies, didn't they? Took the lollies from the Russians. And then, 50 years later, people are like, hey, why aren't we going back? And I was like, no, why aren't we going back? And that's like, no. And now look, we can't do it. They can't do it. Of course they can't do it. Because it's a bridge too far. Right? But because they'd already done it, in the present, right? Gone to the moon, but in the present, and that was 1969. Yeah, it's 1972. NASA, television's just side, but we've got a big present here, haven't we? Hey? They just came the moon, moon buggies up there and everything. Right? This massive present. Alright, and the reason it was possible because of the stuff. Because of the stuff that's in here. Right? Right? That's why it was possible. Nobody questions it. And now, 2023, It's the future back then, but now it's the present. It's always the present. So now what do? They have to tweak the past to make it seem that it's possible in the present again. What's that thing in Top Gun? Yo, Maverick, your ego's cashing checks, your body just, what is it? Your ego's writing checks, your body can't cash or something like that. That's what it is. They take all the lollies. It's like getting paid for a job, isn't it? You get paid for a job before you do the job. Oh, yeah, lovely. Yeah, I'll do it next weekend. Yeah. You get the money, you blow it, and then it's like, damn. But look, it sounds crazy, right? But this is, I can't believe it. And that's it. It is. That's it. That's all they've said. Roma calculated the speed of light as about 155,000 miles per second. Actually, it is about 186,280 miles. 186,000 to. The fact announced by Roma in 1676 that light has a finite and measured velocity is a foundation stone of modern physics and astronomy. Oh, Roma. Wow. Nah. That is amazing. Newton and the falling apple. Mortals, congratulate yourselves that so great a man has lived for the honour of the human race. This inscription on the tombstone of Sir Isaac Newton in Westminster Abbey is a fitting tribute to the great Englishman who gave man new insight into the nature of the universe. For he demonstrated that the heavenly bodies scattered through space, comets, planets, including the Earth, and meteors, are all parts of the same system, and that they all obey identical mechanical laws. With almost unmatched mathematical genius, Newton proved that the same natural force that caused an apple to fall from a tree holds planets in their courses. We call this force of mutual attraction gravitation. The attraction, right, look, that's enough for now. That was awesome, and I swear on everything that I hold dear, not a setup. That was live stuff. Oh, Roma. It was the Danish astronomer Olaus Rømer, 1644 to 1710, who first definitely demonstrated that light has velocity, and who gave the first, but with a telescope, so it does not matter, does it? You have to see that angle. You have to see that angle. You have to see this angle, because this is it right here. Right? It's right over by that fence, right? Now if I... See that knife in the fence, right? Light reflecting off of it from the sun or whatever. So, Jupiter, Earth, you're the sun. Come round. Saw a little penknife, right? So I'm going to time that, and now, 6 months later, we go behind, same distance, right? And I look again. Now, what kind of time delay would there be? Me looking at that, it wouldn't matter where I was. It wouldn't matter how far back I went. If I'm looking through a telescope, right, there is no time delay. because I am watching Jupiter or its moon Io with a telescope. You have to see this angle because it's illogical. It does not make any sense, and that is a fact. All right, that's got to be enough. Oh no, 14 minutes. Oh, this is going to just have to go. I can't do it. I'm not doing 41-minute reel. Look, this was fascinating stuff. There's still more books to go. I'm telling you, the present, they're making claims. They're making claims cannot be made. They know knowledge that can't be known. And when it gets too much, too out of hand, they quick. Oh, look. Oh, that did find out in 1920, this, that, and the other. So maybe it is possible, like that 2 guys in the Cessna. How long? 2 months. Oh, look. Anyway, stay frosty, people. Think and these things. These are gold. These are gold because once these are gone, everything's gone. History's gone. So if anybody has got some, right, and don't know what to do with them, message me. I might buy some. Not crazy, not like millions of dollars just because of this, right? This is in everyone's interest. Keep them. Keep them. Let us know what years you have. You've got to put a picture together. I'm telling you. Look at these things. Still going to find Lagrange, 3-body solution. God, I can't believe I found old Rome alive, but with a telescope. It does not compute. It does not compute. All right. I can get no sleep.